just put it here.
The impact of current technology trends on information management. It seems like that's a topic you all like.
Toby, do you want to introduce yourself, please?
And a little bit about yourself and where you came from.
Okay, good morning, everyone. Did I hear good morning? Can you say good morning? Yes.
Morning, Toby.
We're doing a little bit of energy here, and I know that the coffee is coming, but unfortunately only in 45 minutes. So we'll have to wait for that. But I'll try to make this 45 minutes at least entertaining a little bit. The topic of my presentation is, sitting back there is an interesting thing. You have to see all of the participants here. And what I was doing, in fact, I was, this observation, research, analytics, and so on. So I was counting how many people are using, in fact, most of them, in fact, were using the smartphones, the iPad, there are some laptops, and so on. It's over 2/3 of us having electronic device open in front of you. Some of you were taking pictures of it. Some of you were preparing presentations. Some of them were on LinkedIn, I noticed that. Some of you were just chatting. But this is what the presentation is all about. What is the impact of this information technology on our life, on our work, and especially, because this is the topic, on the information management? It's popular to ask questions, so I'm going to ask a question again. How many of you are on LinkedIn? Can you raise the question? Okay, fairly good number. So instead of introducing myself, I would invite you to visit me on the LinkedIn and find all the information there. The only thing, yes, I do come from the agency. I'm the head of nuclear information section, which does have, and I will have a presentation tomorrow, so I'll talk more about INIS and the rest, but currently it covers library, the IAEA library, INIS, International Nuclear Information System, and a small group of IT specialists. Oh, so this thing is working.
The pointer, the laser is working.
Good old technology, right?
Yeah.
Okay. This is the short overview of the things that I will try to cover today in the next 45 minutes. You can go slowly to it and see it, but generally speaking I'll just make a brief overview of one slide of the way I see we currently stand. Some of those IT big changes and the progress made. Information management, which I'll be very short because Anatoly did a nice job explaining already most of it. I will try to look at the information as an asset, talk a little bit about that. And of course, the main thing is some of the review of those IT trends. And they are the ones you can see listed here. And this will bring us to the end when it's the question of IAM challenges. IAM standing for information management. If you're looking, since this is training school, if you're looking for some learning outcomes, I believe that at the end of this, you'll be able to recognize some of those IT impacts, although you are familiar already with most of them. You'll be able to define the IAM, appreciate information as an asset, and understand relevant IT trends, and of course, identify some of those challenges. So this is a very busy slide, and my purpose is not to make you confused. It is just to maybe show how the world is kind of organized today, of all these elements which are working together or maybe not working. We have 7.5 billion people, most of them living in cities. We have half of them already on the internet. Then you have another 2.7 or 8 million active social, and I just said, 2/3 of people were using or were on some kind of social media already here. We have a great number of smartphones being used. I'm just going to try to see it a little better here so that I don't have to turn there. And these are just some of the statistics, but they are amazing statistics because when you look at it, you know that most of the 7.8 billion people and half of them are on the internet are using this. This is already a tremendous change which we as information producers, information users, we have to take into consideration. some of the things like famous Moore's law, that the number of transistors in a dense integrated circuit has doubled approximately every 18 months. Some people are doubting even that. They're saying it's every 16 months. The computer processing power from 1956 to 1915 increased 1 trillion times. Anatoly mentioned this 3,000 times bigger density and the capacity for storage. And this is another one of 1 trillion fold. I mean, it's sometimes very difficult even to understand the size of that. 75 to 2008, it's a very, very interesting number. We have 1 billion PCs sold. And we said, wow, that's a big number. At the same time, in 2013 alone, we had 1 billion cell phones sold. I mean, this is something that as managers and users and people working in any industry should take into consideration. I won't go through all of that. There is no time for it, but you can, I believe that presentations are available online, so you can have a look at it. I'd just like to go to the last two red squares. In fact, one says 90% of the all data in the world has been generated over the last 2 years. Does it mean that probably within the next 1 year, we'll have another 90% generated? So this is tremendous amount, and I will have a slide about this just to show how big is this big data really. When we are talking about 2.5 exabytes of data that are produced every day, and we've just mentioned there, how much data we are producing, how we can organize, how can we store it, use it, and so on. We have to understand that, every day we are producing 250,000 biggest libraries in the world, Library of Congress. That's something that is sometimes even hard to understand. So if we are to generate all this and put some kind of a framework around it, we have tremendous PC power. We have the tremendous impact of mobiles. We have definitely impact of our own jobs, of all these changes. We have the information which is changing its concepts from, and there was just mentioning here, the data, records management, maybe knowledge management, but there is this concept which we have to look into it as something which is very, very dynamic. There was mentioning also already of expert systems, rule-based, and so on. This was the beginning of artificial intelligence. So yes, there will be a tremendous impact of this on our lives. Robots, which are almost everywhere, although we don't even realize sometimes that they're there. And of course, this big data. In a summary, for the IT progress, we are talking about what? We are talking about 4 or 5 major things which happen. We have a tremendous development, and we saw those trillions of times or thousands of times of disk space and so on. We have boundary pushing innovation, which means that what was a standard yesterday definitely is not today and will be completely changed tomorrow. This is something that you as young specialists will have to take into consideration while you're doing and organizing your own work or the work for others. This also means that we have a constant change. As soon as something becomes a procedure or a process and so on, the worst thing to do is probably to stop and say, okay, fine, we have finished it. It's exactly the same moment when you finish something to say, okay, fine, let's look at it critically and see what can be changed, what can be done there. This is all done in a very fast pace. And the last element here, which I'm saying the social technology gap, I'd like to explain this. We have reached amazing technology development, but many scientists around the world, and philosophers, thinkers, and so on, they say that the social aspect, our human existence, haven't kind of matched that technological development. Where is the proof? The proof, for example, is today's discussion, literally today's discussion about the impact of artificial intelligence. We have the greatest minds in the world saying, don't ever touch that. Don't do that, because that will be the end of humanity. And then you have some other people, leading politicians around the world, to say, like, who masters AI will master the world. So these are just some of those social technology gaps that we will all be faced with. just very briefly, because Anatoly did an excellent job with this one. If you're talking about information management, you have to say, okay, fine, what is information? And there are zillions of definitions and misunderstandings and so on. The simplest one probably is to say that information is data presented in a form that is meaningful to a recipient. So this is probably the only thing that we could generally agree on. We have the information management as is the collection and processing of information from one or more sources and the distribution of that information to one or more audiences. So here, important to understand is that you collect, you process, and what you do, you disseminate. So these three elements are the basic ones, and then you can see here on the right side, you have this more or less famous wheel with the steps or phases that information management can go through. So I will just skip that and go. But it's also interesting this is not one of my most favorite pictures about information management, and this, the famous pyramid from data knowledge, information knowledge, and I even hate to say wisdom, but yes, it is there. But what's important here is, in fact, this something in between data and information. That data has to be put in a context to become information. And then if you have the information and you have some meaning or add meaning to it, you might be talking about knowledge. And I'll skip the last part. This is, in a way, somewhat sad part of this presentation. When you're looking, for example, of the current status of management, particularly of the bodies or units that are doing that, because we do have that libraries, information knowledge centers are disappearing. And I do have a number of presentations, some of them you can find it on the LinkedIn, talking about disappearance of libraries. We are saying, wow, libraries are great. And when it comes to the question of budgeting and sourcing, so on, that's the first place to cut. And probably the next one is the archives and so on. We have also a tremendous amount of decrease in information management staff professionalism and decrease, in fact, of their professional work. What do I mean here? How many of you have gone to a library or information center and somewhere you have found a volunteer? I have nothing against volunteers, but there is this tremendous trend of putting people who are not really qualified doing this work, which literally diminishes the work of the professionals. There is the problem of budget. The price of external content is increasing. It's increasing over 10% a year. So no wonder that some of the journals, for example, in nuclear science or nuclear technology, they go up to 20,000 euros a year, one single subscription. We do have a problem with the cost of new systems and applications because the cost is also high. Everyone is talking about intellectual property protection, and it's a very, very difficult thing to do because we have, first of all, to change something in our minds, the way we think, the way we consider information. We should consider it as an asset, right? I'll talk about it. So it's not everything free. We cannot get requests everywhere, left and right, to get the information. So this is the protection side. The other side is open science, the open access, and all this open movement, which are requesting from people, we want that. So what is happening is that on the one side, there is a very strong, this commercialization of all aspects of information management. On the other one is that, we would like to have it open. Why? Because we believe that, the social aspect, which I was talking on, which is not well addressed, needs better access to this information to resolve it. So we do have a number of open access initiatives. You have a number of, even in my presentation tomorrow, I will talk about a little about information resources, and I will mention some of those open access journals or open access repositories and so on, which helps, in fact, overcome the problem of access to information. We have, of course, amazing competition, which comes in the form of Amazon, Google, and some other ones. I like this notion that everything is already on the web. INIS is one of those systems that has over 4 million records there, and 1.some million are full text. And people always say, but why do we need you? Why do we spend money on you? Because it's already on the web. There is one missing question there, or should I say answer? The answer is someone had to put it there. And most likely those were people in INIS who did it. So we did analysis of that, and we found out that a great number of our own records are uniquely available only from us. That's also added value to information. Talking about information as an organizational asset, and I love this cartoon. This is one of those in a book which was devoted, in fact, to this. I took it there, which is a copyright breach, by the way. It's the question, what do we really, we all say, okay, information is very important, it's valuable, it's asset, and so on, but do we really know what we are talking about? This particular asset, you know, if we are to forget about information, and if we are to read just the bottom part, and you say the asset cost millions, and nobody can tell where the asset sits, its quantity, or where it came from, there is more than what a regular human brain can process. Many claim that they own the asset, the question of accountability and responsibility. It is not recognizable on a balance sheet. And everyone say, well, what are you talking about? Well, we are talking about information. That is one of the things which there's a little bit of a moment in accounting business that information should be put on a balance sheet as an asset, but it's, I believe, far away from, at least a number of years away from really doing that. One of the last parts there is like when they say that there is no measurement, no management. And that is very, very important. So because, yes, we have 4 million records in INIS, we have hundreds of thousands of documents and books in the library. So what? If we don't measure the impact, if we don't say that, you know, we have monthly over 2 million visits to our web page or searches, maybe that is the only thing that you can say, okay, fine, it is valuable because it's measurable. So that's something important for you to think about every time you, and you're most of you engineers, when you think about something, well, I have to measure it, I have to know the dimensions, I have to know the values and so on. So this is probably one of the things that needs to be done. So here we go, information as an organizational asset. First of all, when we are talking about assets, we are talking accounting. In a balance sheet asset, that's their definition, anything which is tangible or intangible that organization owns or controls and that holds value or can produce economic benefit. This is very important to understand that, you know, in balance sheets and so on, the asset needs to produce some benefit. If you're talking about information asset, that's an identifiable collection of data or information stored in any manner, any type of storage device or form, and recognized as having value for the purpose of enabling an organization to perform its business functions, thereby satisfying recognizing business requirements. It's a long definition. But the point is, yes, if there is a value for the organization and that value has to be measured, that's most likely information asset. So every time we are dealing with something, you know, there's always this beautiful thing of, I would love to keep it. I would love to have it. So let's store it. The question is, what is the purpose of that? What should be done with that at the end? Is this going really to make some kind of benefit for the organization? And it doesn't have always to be in dollars. It should be in dollars, but it doesn't have to be always money value. It has to be the value maybe of improving the processes, making better decisions, and so on. Here you have the characteristics. I won't go through them because you can probably, or you have probably already read them while I was talking. But yes, they are very important. They are mostly, we would call them general ones. Like, for example, the relevancy, sometimes very difficult to define. Timeliness, very important because no one wants to see statistics which are 5 years old and make a decision based on them. So there's a number of these prerequisites which, if properly implemented, organized, and managed, would make the information as an asset for organization. The reason I put this block here on the right side, where I talk about two theories of information, and that is, I believe, an important thing an important difference to make. We have a little bit traditional way of thinking, and thinking of information as some kind of a tool for control. So what we want is information is used to alert us to a deviation from our plan. So we have a plan, we make a one-year plan, we have meetings, this and that, and we would like to have information coming, telling us, okay, fine, this is working or this is not working. This is a little bit of a traditional way of looking at information. And yes, it works, and we should probably have that one. But what is much more important is to have this different view of information when we are looking at information as a learning tool, as something that will help us adapt. And what do I mean by that? It's used today's, these are turbulent times. We have fast-changing world. We have request for persistent change, the uncertainty in that change. We need to make decisions quickly. We have to go under different changes, be it HR changes or financial, there is pressure there and so on. So the information in that sense should be used, in fact, to make proper decision in proper time. So it is a little bit of different, as you can see. It's like the previous one, which is controlling and saying, okay, fine, this is the way it was. This is more saying, okay, fine, this is what we have, maybe the suggestion ways, so on. So if you are thinking about the role of information, it is preferable that if we make this little switch to seeing information in this decision-making process for something for future. My last slide about organizational asset, and I really like this because it's a very simplified model. It takes three basic elements. It looks at information where the value is already realized. That's when we have the information and all the elements of the information are currently available and are being used. So we have, for example, I don't know, the set of databases and so on. It's all set there. Everything is fine, and that value is being realized. The next step, in fact, is that it is based on expected capabilities and plans. In other words, we are planning what we could do with this. So it's not like we are just doing it, we are using it, information source is fine, but it's the thinking of what can we use it for? Is there something else that we can do with that? So this is the question of, and they put it nicely there, this is the realized value and probable value. And the management specialists would look at it and say, well, you are talking here with a very blatant, in fact, performance gap. So when you have this performance gap analysis, okay, this is what they're looking at. This is a realized value, and this is the probable value that we can identify through this and come up with some. What's very important, in fact, is this potential value. This, if you apply the data to all relevant business processes, what will be the future outcome of all that? And that's so-called this vision gap. And by the way, this is not what I invented. This is by Gartner, which I'm not marketing Gartner here. I'm just saying that they do have amazing information resources regarding trends and impact on industries and so on. This is one of those slides that you probably will have a headache just looking at it. So don't look at it. Just listen. What I try to do here is, it's like there are different ways of analyzing trends. So I said, okay, look at the most organizational consulting companies, groups that have the biggest impact on the way organizations manage them. So I took Gartner, Forbes, Forrester, Deloitte, and Accenture. And I only made each one has one of the reports, and you have the reference there. It's only Deloitte that has two of them, and I'll mention it why. So if you look at some of them, you will see that there are, in fact, similarities. And I will go on the next slide when I talk about what is important for us. But yes, you can see that many of them are talking about augmented reality, the virtual reality, Internet of Things, big data, and so on. The reason I put this as an emphasis is because this is probably the only one which is talking directly about the human impact or the human capital, because they call it, I think, human capital trends. And that's Deloitte did it. And this is a very, very interesting read when you look at it. It will impact the organization of the future, that we have the talent acquisition problems, that we have the performance management, that there is a digital HR, diversity and inclusion, careers and learning, and this is exactly what we are doing here, career development and so on. You do have the references here, so if you ever want to visit, you can find them on the web and go and read the details. When I analyzed all the ones that we just had so many of them listed there, that's the reason you don't pay attention for that, I kind of picked up the most important ones. And the most important ones are these, in my opinion, these 6. So we are talking about AI and machine learning. AI stands for artificial intelligence, virtual and augmented reality, Internet of Things, digital platforms, big data, and analytics. Time permitting, I will probably go through each one of them because I do have slides. I might go through some of them a little faster, but you still have the reference there. And I believe it was already mentioned at the beginning of the school that all of us working at the agency are open for communication. So if you do have later on any questions, problems, or you would like something else, please contact us. And there will be, at least my email is there, and I think that it was done for everyone else. So when we are looking, yes, why did I select them? I selected them because I believe those are the main disruptors of the industry and the processes we are doing. Because some of them, yes, there will be changes, but I believe that these will be the changes which could be categorized as, in fact, major disruptors. So, artificial intelligence. What is IAEA? Those are the systems that can think and act rationally like humans. There is a huge debate what's artificial intelligence. This is probably one of the simplest definitions, at least to understand that, yes, there is this human element in there. They're very complex for development and maintenance and also for deployment. And you will find them everywhere. It's not just, that we are talking about high-tech industries. You will find them in artificial intelligence, for example, in washing your own car. Yes, there are sensors there are robotic arms, they're this and that, and they know that, okay, fine. So yes, that's one of those simple ways of using it, but it's one of the ways. They do combine different technologies and techniques. Some of them, I believe, were mentioned here, like deep learning, neural networks, NLP, and so on. They move beyond traditional rule-based algorithms, because that was the beginning when Anatoly mentioned the expert system and so on, rule-based. That was the beginning of artificial intelligence. They have moved away from that to create systems that understand learning. They can learn by themselves, they can predict, they can adapt, and potentially operate autonomously. And that last part, in fact, is the one that bothers many philosophers because, well, what about if they turn against the humanity? But that's a different topic and different discussion. They are built into physical devices, so sometimes you don't even know that they are there. If you see a robot, you'll probably figure out, okay, there is AI somewhere inside. They're built into cars, they're built into consumer electronics, security apps and services, like, for example, virtual personal assistants, smart advisors, voice recognition, vision, translation, finance, and so on. Anyone knows how many sensors are in a simple car? Just a number. 10. There are over 100. Already, in a very simple car, there are already over 100 sensors which, in fact, are somewhere connected to AI. So this is just to show that, and by the way, as soon as you see some kind of a warning lamp or something going on, you can say, okay, fine, this is some of the sensors that are telling me something or whatever it is. So this is the very specific use, and you have them in any type of industry, starting for, God forbid, in aviation, when you have on the aircraft and you have some red light there, which could be a light threatening, to any other one like nuclear power plants, and even if you're talking in administration, which is far away from really using that, you can have those dashboards and so on, where you can have that. And Alina is looking here at me, and she said, "What? Well, what we can have is that that we are under the budget. We are spending too much money," and she's flashing the red light that we have to do something about it. So the last thing is also interesting, that AI becomes a new user interface. This is somewhat difficult to understand, but what it tells us that, we don't have anymore the static interface to any type of device. We might have something in between, which will tell us, okay, fine, this is important for you, this is not important for you. So it becomes a completely different way of accessing tools and information and such. Virtual and augmented reality. A little bit of definition. VR, and I like this one, VR takes us out of reality and brings us to some other place. While the augmented reality takes our current state or reality and adds something to it. So it's a little bit of thinking to do, but it's probably easier if we compare them. So the best one that I could come up with is this virtual versus augmented. When you're talking about the scuba diving, where you have the real emergence, you have the appearance of that, you're part of that environment, and then you go to the aquarium and you see something. Virtual reality can bring us to a construction site, for example, where we can walk in any direction and see every single detail. Augmented reality is helpful for a client who can't visualize something. The idea is that a designer, for example, an architect and a homeowner, who sits around the table and look at the same 3D model table instead of the famous 2D plans and makes decisions. Human mind is not able to tell the difference. That's a very dangerous thing here. But that is the fact that the human mind, unfortunately, is not able to make the difference between computer-generated images and the real world. This is being used and abused probably in some of those games like a Pokemon Go, when you go and see people that they're doing something and you're like, what the hell, there is nothing there. So yes, this is the type of the impact it might have on some completely different aspects of our life. And yes, they're being used in military, medical science, nuclear science, manufacturing, real estate, and so on. Internet of Things. It's a system of interrelated computing devices, be it mechanical or digital. The objects, it could be also animals or people that are provided with a unique identifier, and the ability to transfer data over a network without requiring human-to-human or human-to-computer interactions. Putting simply, what do we need for that? Okay, we need the unique identifier, the IP. We need some kind of a Wi-Fi connection, or Wi-Fi connection. We do need sensors, here we go again, okay? And we need electronic circuits which will collect the data and transfer it somewhere and probably process it. So as you can see, those elements are very simple, but once you put them all together, their impact is tremendous. So a thing can be goods, it could be objects, machines, appliances, they could be buildings, they could be animals, they could be people. Where things becomes very tricky. They could be also, believe it or not, plants and soil, and some other ones too. So for example, a person with a heart monitor implant, in this world of IoT, can become probably the happiest thing or person in the world, because that thing worked and informed his doctor there is a danger and so on. It could be a farm animal with a biochip transponder saying, okay, transponder saying that, okay, fine, that specific cow needs to be milked or something and it's far away. And so there are different types of uses. Most of them should be okay. Some of them are questionable. I already mentioned these cars and so on. They could be connected and learn about food, monitoring supplies, search, location, managing cities, control use of electricity, game immersion, and so on. Since we are here in Italy, there was a very interesting example of, I believe it was in Bologna. It was the supermarket chain that introduced this type of technology to help people make choices of food they're buying. So yes, you can just come to something and suddenly on the screen you will get everything. This is the origin from there, this is this, it's good for that or not good for that. And it was a tremendous difference between once you go and see, okay, the price for this is 10 euros. Okay, fine, maybe I buy, maybe I not. Because this involves the actual consumer much deeper than just having a thing. And then, yes, you can even ask questions, you can use your search and so on. So as you can see, the possibilities are really, really great. What's important here is that, and that is the most important part of that we are moving from a standard way. We are moving from people to computer creating and capturing data. And that is, because we have things now communicating and generating tremendous amount of data, putting it somewhere, if they're putting it, and storing and so on. We have, of course, amazing complexity. There is a problem with policy, which is in this, with the privacy, sorry, because in this particular case, it almost does not exist. And they're also saying that could be a weapon of mass disruption. There was a joke about this, the mass disruption of these things. If you hook someone like your spouse with that and that the spouse is not really at the place where it's supposed to be, so yes, it could be a very massive disruption in that particular case. But there are many, many things. The digital platform, I just go briefly through that, because digital platforms it's a technology enabled business model, in fact, which is being changed, that creates value by facilitating exchanges between two or more independent groups. Networked effects, the value increase as more members participate. Big definition, right? Hard to understand. But look at the bottom there. Those are the example of those digital platforms. So for example, in advertising, you have Google, you have Baidu, you have Tencent, Redirect. In social, you have those platforms like Facebook, Twitter, Instagram, LinkedIn. In commerce, the most famous are probably Amazon and Alibaba. In application stores, there is an Apple Store, there is a Google Play. Those are the examples of digital platforms. What are the benefits? The benefits are, simply put, revenue, brings together end users and producers, and that can transact easily with each other. You go to Alibaba, you made a query, you have zillions of those sellers who would offer you something. You can choose, you can bid, you can do all kinds of things. You can do the same thing with any of those. So there is a much bigger possibility to generate revenue. In fact, saving on one side and revenue probably on the producer side. It's also the question of reducing cost. Sometimes it's order on demand, or production on demand, or print on demand. It depends what you want. So this is one of the ways that, if you have the systems well connected. There is a collaboration through different technological devices or softwares, APIs, and so on. There is a portability, because that's most of the time based on a cloud, and other technologies which provide that. And there is a question of protection, which is a questionable one. It's intellectual property, which needs to be protected even through digital platforms, because there is invisible change that some process that some transaction goes through, but at every step it needs to be protected. This is one of my favorite slides probably here. We already talked about how big is big. So if we assume that 1 byte is a grain of rice, what is a kilobyte? A kilobyte is just 1 cup of rice, right? And then we are talking about some of those very old computers. We are talking about hobbyists. We are talking about some little small stuff. What is a megabyte? If you take that same rice, the grain of rice, the megabyte would be 8 bags of rice. Okay? That's the gigabyte. We are already talking about 3 semi-trucks, and you probably know what's a semi-truck. It's the big trucks, 8-wheelers or 12-wheelers, whatever they call them, the big ones. So it's 3 of them for 1 gigabyte. And there we're already talking about probably a desktop. If you're looking at terabyte, and most of us have already storage devices either at home or in office, which is 1 terabyte. And it's nothing big, right? 1 terabyte is 2 container ships. And that container ships is not 1 container on that, it's thousands of containers on that ship. And it's 2 times 2. These examples are from US, so they're talking about what's the petabyte. It can blanket Manhattan. Major part of New York, huge part. So if you put everything there next to each other, those grains, that's the petabyte. And that's what we are talking about today about internet. That's how big internet is. If you are talking about big data now, we are getting to something called exabyte. That one can cover, it's again a US example, West Coast. So in other words, it can cover more than the whole of Europe. That's how big it is. Zettabyte, and I have an article written on Google somewhere about zettabytes, how big it is, how many thousands of Library of Congress you can fit into it. Zettabyte fills the Pacific Ocean. That's big data. And then something that we can probably not understand, and there are people already talking about it, the size of big data, yottabyte. That is literally an Earth-sized rice ball. So you can imagine how much data it is. So there was a question there, how do we manage that? We can probably go as far as the internet and manage some things, but if you're looking at the future, we do need new devices, we do need new software, we do need analytics tools and so on, which will help us manage all this. There is no solution at the moment that we can successfully. What everyone is doing, when they say big data, okay, fine, they take a chunk of this, they call it the big data. For some of them, it is very big, and they try to manage it for their own purposes. If we are talking globally, or if we are talking some specific over industry things, it's so far difficult. There was already mentioning of this. I just won't spend time on that. There is the question of volume, data in rest. When we're talking about this one, and those are those exabytes of data. There is variety, different formats, veracity. That's the question of quality, redundancy, and so on. And of course, I already mentioned this, the question of value. And this is known as, 5 of them, but it's known as 4 V's. Because the last V, which is value, was added later on. Now they're saying that there are even 6, 7 of them. But this is just like maybe getting overboard. So these are in fact 5 V's of big data, of information, put in a I would call theoretical model. And I like also this data in motion, which is velocity, rate of creation, which is tremendous. How does the scientist cope with all this information which comes to him or her? Very, very difficult, because it is impossible. We just went through a slide, how much data is created daily and so on. Analytics. And I took this definition from the Institute of Operational Research and Management Science, which says analytics is the scientific process of transforming data into insight for making better decisions. So as you can see, it's a bit of a different view and take on analytics itself. I am mentioning here that the business analytics explores past performance to gain insight and drive business planning. And there are different types, which could be a descriptive, the descriptive one, which that's the type of analytics that most of the organizations are using currently. And there could be also the predictive ones. Different applications are thank you, 5 minutes, yes. And the last one is that from here, we have different technologies listed, like data management, data mining, text mining, and Hadoop, which you probably already know about. And the opportunities, similar to the previous one when I mentioned, there's a cost reduction, fast and better decision-making, new products and services. We're coming very close to the end. This is the IAM challenges, information management challenges, based on these technological changes or trends. I have listed 4 of them. These are the first 2. This is from the aspect of an organization and from the technical aspect. From the organization aspect, it's disappearing IAM units, available financial and human resources, business focus, very important, and competition with the big players. From the technical one, changing technical requirements, long-term preservation, Anatoly talked already about it, multitasking, rapid delivery, more difficult access to information, interconnectivity, interoperability, and affordability of top-of-the-line analytical tools. Because anyone who ever wanted to purchase some of those tools probably was shocked by the price it was given there. And finally, I had to skip something. Finally, the conclusions could be different ones. I'm not making any conclusions. I'm leaving it up to you. I'm just listing here some of the elements for making conclusions. Those are the elements that we already have. We have big data, we have robots, we have sensors, someone mentioned already nanotechnology there, virtual reality, cyber-physical system, cloud computing, emerging technologies, AI, IoT, smart devices, real-time analytics. But when you look all that, just please remember one thing. Out of all this presentation and all these 45 minutes, if you remember one thing, that would be very valid. And that's, we are entering the Industrial Revolution 4.0. And if you want to maybe explore some of these trends, you can literally forget about whatever was written there and try to read a little bit about what is this Industrial Revolution 4.0 all about. And I end up with one little story. CEO of Mercedes-Benz, was recently in an interview asked, who are your biggest competitors? Any guesses?
Also, Apple, Google.
That was very close. Yeah, because people were expecting it would be Toyota, it would be GM, or I don't know what. No, he said it's Tesla. It is Google. Why? Because he said in the car industry for years, what we have been doing, we were improving something which was more or less the same. But we were improving it. These guys, they said, forget about the past, and they are doing something else, something completely new. It's disruptive. Those are my biggest competitors, he said. Thank you very much.